that a sign chart is just a tool. We don't get to use it for our explanation, but it can help us kind of plan our explanations, kind of like right in the draft of an essay. All right. So first thing I'm noticing, I've got a differentiable function defined on the interval between -5 and 6. The figure above shows the graph of f prime, the derivative of f. The graph of f prime has a horizontal tangent at -3. I'm not sure that comes in. It might come in here in a minute, knowing that there's a horizontal tangent there. The area of the region between f prime and the x-axis from -5 to -1 is 5. So this is actually 5 because that's not a circle. It's probably part of a parabola. F prime is piecewise linear on the interval between -1 and 6. The function satisfies, ooh, what's this thing here called? I don't think we're going to use it yet, but what's that thing called? Yeah, we've got an initial condition there. Good job. All right, so on the interval between -5 and 6, state the critical values of f of x and whether it's a relative max, relative min, or neither, justify your answer. So the very first thing it says is we have to state the critical values. Where do we get the critical values from? Okay. See a lot of different, I've seen zeros, okay? More specifically, we need the zeros of f prime, right? So I would want to state something that says f prime of x equals 0, and you want to say that that implies or that means that the x's are, the zeros are. So where are the zeros? What did everybody get? What did everybody get? And at this point, I know that you guys have the answer, but you want to make sure your notation is refined. This is kind of our last little bit of putting those finishing touches on that notation. All right, anybody else? Good morning, Jacob. All right, good. I'm liking the -1 and the 2, perfect. Okay, so now I'm going to get out my sign chart, and we're going to get out Mrs. Ballard's crazy sign chart. Okay, and I'm going to actually draw a fairly big sign chart because I'm going to add more to it in a little bit. Because of what happens later on. So I'm kind of leaving room for growth in my sign chart. I'm going to put my intervals here, and I'm going to put my what's going on with f prime there. So I know that I'm ending at -5. I have a 0 at -1. I have a 0 at 2, and then I am ending at 6. All right, so we would look at if it, because it's a derivative, so we want to look at whether you're above the axis or below the axis. So can you guys tell me what signs, what the signs are for our 3 intervals there? Put them in the chat for me. What signs did you get? Okay, good job, everybody. I'm seeing lots of good things. So plus, minus, plus, perfect. All right, so we have to decide relative max, relative min. All right, so if your first name starts with A through, let's say, L, A through L, I want you to put the relative max in the chat. If you're L to Z, I want you to put the relative min in the chat and label it min or max, okay? All right, I've got a map. Sorry. Lorenzo, I gave you both. This is A, B, C, D, E, F, G, H, I, K, L, M. M through Z. Okay, I got the maxes. All right, where are my min people? Where's my M through Z's? All right, we've got a min at x equals 2, relative min at x equals 2. Perfect. Okay, so they remember, we're just going to go through justifying that one more time. Hopefully you have your justification down. Okay, so you'd want to say that f has a relative min at x equals, we said min, right? This was the max. We said min at 2. At x equals 2 because f prime changes from, and you're not going to be lazy like I am right now on the test, okay? From negative to positive. Write out the words negative, write out the words positive. F has a relative max at x equals -1 because f prime changes from positive to negative. Okay, give you a minute if you need it. Couple of
Hey, Mrs. Ballard, on that first part, would you consider -5 and 6 critical numbers also? Since that equals 0? Because I feel like I usually do. But then I know it doesn't matter on that interval because of -5 to 6, but
I don't know. It depends on if, like, I normally think they're just endpoints, and endpoints aren't, I mean, yeah, they would be critical, but because they're endpoints in this particular part, it doesn't apply.
Well, if the question had just said name the critical values of f, then you would include them?
Yeah, I think so.
Yeah, I would too. Okay.
I don't think it would hurt to include them because technically they are, but then you wouldn't, you would use them as endpoints. So I don't think there's, in that case, I don't think more is going to hurt you in any way. All right. The good news is increasing comes right from the same sign chart, right? Uh-oh, does somebody have a question, or was that? Yeah, Gabby, what's wrong?
Okay, so you know how it says to state the values and do the relative mins and max. So does the first part count as like your statement of the values? Like, do they understand that?
Yeah.
Okay, thank you.
That's why you want to, and even if it doesn't say to state that values, you want that line, it's usually worth a point. Okay, so it's not, don't leave that line off. Okay. All right. So, on what intervals is f of x increasing? Okay, what do we get for increasing? Put it in the chat for me, please. What did you get for increasing? I'm hoping there's a delay in my chat, because I'm not seeing it. Oh, here we go. Here comes Gabby. All right. Mrs. DeWitt, do you keep them open or do you make it closed? Oh, you use closed?
For what?
On the intervals, do you ever use closed or do you just leave them open?
I usually leave them open.
Me too.
But there's all that talk now on our Facebook page about that.
So usually they say that they'll take it either way.
Yeah, so I usually go with open.
And then do you still use the U in between or do you just use the word and?
I usually use the word and.
Yeah, I switched back to and instead of the U because there's some kind of weird conjunction with the U and I'm like, okay, we'll just use and.
Yeah.
All right. You guys are correct. Those of you that helped out and answered. And I did see some closed intervals. And like on this particular one, that's probably not going to be a problem. They're probably not going to look at open and closed because all teachers kind of teach it a little differently. So they don't mark you down on that.
Although I would say on this particular problem, because of the interval that they listed on they gave us an open interval, so I wouldn't use closed in this case because it specifically said on the open interval, -5 to 6.
Yeah, that's true. That's true.
Oh, although that was part A.
That was part A. Part B, they technically say.
Put that back.
Yeah, technically on part B, maybe not. So, and they said closed earlier on in the problem too. So, anyways, I don't think they would mark us down.
But actually, so after I don't think we'd get marked down either. And in fact, I think the question on the test would probably say on what open intervals is f increasing. But I do think the new way that I've been reading about is you would do brackets for the increasing part. You would include the endpoints.
Okay, cool. All right, but yeah, they're probably going to say open intervals. We're going to go with open intervals right now. So we would say that f is increasing on between -5 and 1 and 2 and 6 because f prime, remember, because they gave us f prime, that's what all of our answers should be based on. F prime is changing. Oh no, is changing. Is positive or greater than 0, right? I went to the wrong explanation. Is greater than 0. Or you can write the words is positive. It's -1. Oh, thank you. Typo. Okay. All right. Where'd you guys get concave down? Oh, we haven't done concave down yet, have we? So tell me, where did you guys think concave down was? And then I'll add to my sign chart. What'd you guys get? I must have a huge delay this morning. I know you all have done it. Have you all done it already? I gave you 5 minutes. Gabby says she came late. All right, then I will go ahead and start it, and then you all can help me. Oh, Lorenzo's got it. Lorenzo, concavity is going to be open no matter what, okay? So no closed on concavity. Again, I don't think they would mark you down, but no closed on concavity, okay? All right, so we want to look at places where you're changing from positive to negative. And again, I know you can read this right off the graph, but I always use a sign chart for it. So I use a double layer sign chart. So that, because later on I'm going to need this, okay? Because I kind of previewed my problem a little bit. So anytime I have a horizontal tangent, so at -3, I'm going to add a fence. And then here I notice I'm changing, and here I notice I'm changing. So I'm going to add a fence at 1, and I'm going to add a fence at 4, okay? In my first row, I'm going to keep my same sign. So I know from -5 to -1, we're going to be positives. And then this interval is going to be negatives, and this is going to be positive. So I didn't really change anything there. I just kind of added on. All right, so remember in this row, we would look at increasing, decreasing, okay? So my first, from -5 to 3, we're increasing, so it would be positive. From -3 to 1, we would be decreasing. So I'm going to have negative in my sign chart, okay? What are my last 3 signs? So in the way I have it set up, what are my last 3 signs? All right, perfect. I'm seeing a lot of plus, plus, minus. So we were increasing, decreasing, okay? And some people just do the 1 to 4, and they just do the increasing over that whole thing. Okay, so now we're looking at concave down. So you guys help me out again in the chat. I know Lorenzo had it in there, but help me out. What is everybody else seeing? Let's make sure we agree. What do you see for concave down? Okay, Tina says -3 to 1, 4 to 6. Gabby, what you did is fine. I would probably do the whole interval though, because they're right next to each other. Okay. All right, I'm seeing lots of -3 to 1s and -4 to 6. Or sorry, 4 to 6. So F is concave down on -3 to 1 and 4 to 6 because, and again, because they started us with F prime, we want to make our explanation the F prime explanation. If we don't, we need to make a connection between F prime and what F double prime is relationship is to it. Okay, so this I always think is the easier explanation because F prime is decreasing, because that's what the negative means, decreasing on these intervals to make my sentence complete as math people are going to make a sentence. All right. The good news is I get to use a sign chart again. They just basically did all of the curve sketching in one little section here, huh? It's okay. It's my favorite stuff, right? All right. Who else likes curve sketching? Raise your hand. This is fun. Jenna, I would say, is that a double prime? You have, Mrs. DeWitt, correct me if I'm wrong. We have to, they have to make a connection between the prime. They have to state something about F prime.
Yeah, you should always refer back to the graph provided if possible. So in this particular case, because we have the F prime graph, we should say that since F prime is decreasing. Yeah.
Yeah. Okay, I'm going with Mrs. DeWitt. And Gabby, you can't say that F prime equals F double prime. You can say maybe implies.
You could say the derivative. You could say since the derivative of F prime is negative.
Yeah, you could say that. There we go. That's a better explanation. Okay, but definitely don't equate F prime to F double prime. Okay. All right. So tell me in the chat, where are my points of inflection? What X values? Help me out. What X values? Oh, Erica was ready for me to ask the question. what would we do to the increasing, decreasing concavity if they gave us the graph of F? Okay, so if they gave us the graph of F, you would say that they're not 95% sure they're not going to give you the graph of F. But you would do what we're doing with the second derivative, Gabby. You would talk about the increasing, decreasing nature of it. And then you would have to, I don't know, they would not probably go to second derivative if they gave you the original graph.
No, but in that rare case, if they would, then I do think it would be okay to say F double prime is greater than 0 if they gave you the F.
Yeah, but that would be a really rare case. They like to give you the one in the middle so they can show you going up and show you going down. So, okay. All right, I like what I'm seeing, you guys. So, F of X has points of inflection at X equals -3, 1, and 4 because F, let's see, double prime change, or no, F prime, right? Got to go F prime changes from increasing to decreasing, and this one seems a little longer, or decreasing to increasing. At these values. You can also be specific, and whichever, we could have been specific, -3 changes from increasing, or whatever it is, and -3 went from increasing to decreasing, and be specific about it, or you can put the or in there. What if they give you the graph of double prime? Then you can only go up, right? You could only do it would be like having the graph, it would be like what we're doing here, and you would be able to talk about the first derivative. Okay. Does that make sense, Gabby? Okay, perfect. All right. Last part of this, or the 5-minute stuff that we had talking about, where are we concave up and decreasing? And this is why I use the double layer sign chart, right? Because concave up and decreasing means that we've got a positive on the top and a no, wait a minute, concave up, other way around. Negative on the top, positive on the bottom. It looks like I've only got one place, right? But I can see it so quickly with my sign chart. Okay, they typically will give you 2 places, and they're hidden with this. One of them is usually hidden pretty well. So that's why that double layer sign chart kind of beats the problem. Gets you to may have a win on that one. So F prime. So we would say that F is concave up and decreasing on, what did I, 1 to 2. Is that right? Because I totally lost it. Let's see, 1 to 2, thank you. On 1 to 2, and this is always open, okay? Because you can't, because concavity is open. And 1 to 2, because, let's see, F prime is, actually help me on the chat. What's going on with F prime? What would be our explanation? What would, based on F prime, what 2 words do I need to show here? Or what 2 things do I need to show here for my explanation? I want to see a few more people. I want to make sure we're here and awake. All right, so I'm seeing increasing and less than 0. So it becomes F prime is less than 0 and F prime is increasing. Okay, that says increasing. Those that have had me for a few years understand my handwriting. Okay, I'm going to do a couple more sections of this one, and then we'll see where we're at on time. We might take a quick break, and then it'll be Mrs. DeWitt's turn. Okay, we have to find F double prime at -3, F double prime at 0, and F double prime at 4, or explain why they don't exist. What's the double, if we started with graph of F prime, okay, We're in the graph of f prime. What's the double prime mean we're going to be looking at? All right, I see a whole bunch of slope in the chat. A whole bunch of slope. Okay, so f. So we're going to find the slope at 3. So let's go to the graph. We're going to find the slope at 3. Oh, interesting. Did they tell us anything about that? Does anybody see anything in maybe the stem of the question that would help me with the slope right there? What's going to help me? What words in the stem are going to help me? Ah, there's a, it says right in the middle of the stem that there's a horizontal tail. It had to be important somewhere, right? That was our indicator that we had a 0 slope there. So we know that that one's going to be equal to 0. Okay. F double prime of 0 equals, okay, so I'm going to go to 0 on my graph. Now, I pulled these problems from somebody who made them up. I particularly am not a fan of his scaling on his graph. So College Board scales usually making it look a little bit more even, but this is a really good exercise. Horizontal tangent at x equals, okay. This is a really good exercise in making sure you're reading your graph very carefully, okay? And so maybe it's a good thing that this one isn't scaled quite to the way I would want it. So we are down 1 and over 1, it looks like, right? So it looks like I've got a -1 slope going on there. So that would be -1, okay? And then for f double prime of 4. F double prime of 4. What do we think the slope is right there? What's the issue with that right there? Okay, I like that it does not exist. Unfortunately, we can't use corner as the explanation or sharp turn. That's what we say in our heads when we see that, right? So the explanation that we have to use, there we go. Okay, it's more towards limits, right? So we got to talk about the right and the left-hand limits. That's what they're testing you on that one, is the limits. So probably how I would start this one, okay, or this part of it, is I would say that I would look at my right and my left-hand limits. So limit as x approaches 4 from the left of f of x, I'd find that value. And the limit as x approaches 4 from the right of f of x. So when you see that corner, you see that sharp turn, you need to, in your head, go, oh, I need to do limits, okay? All right, so let's go ahead and look at those really quick and see what we got. So I'm going to still look at the slope of because we're looking at, actually, I think I wrote that wrong. It should be of f, should be double prime, right? Okay, so I am going to, and this is kind of tough to read, so I'm going to go from here to here. So I know that this is 2, and I know that this is up 4. So I know that has to be 4 over 2, which is the slope of 2. And then this is just the opposite, right? We're still over 2, but it's down 4. It's down 4 that time, so it's going to be a -2. So our right and our left-hand limits, yes, it's just the slope. So our right and our left-hand limits do not match. So I would say that f double prime at 4 does not exist, since the limit as x approaches 4 from the right of f of x does not equal the limit as x approaches 4 from the right of f of x. How are we doing on that one, guys? Give me a smiley face rating in the chat. Where are we at? Are we good? Jenna, what's wrong? F double prime, Gabby, I think yes. Oh, yes, thank you. Is that what Jenna was trying to catch me to? Typos. You all are right. I'm wrong. A good thing you all are taking the test on Monday and not me. All right. Last one that I'm going to do with you, and then I'm going to let Mrs. or actually we might take a little break, like 5-minute break. All right, fine, because this is a big one, isn't it? Absolutes, they take a little bit, okay? What if they asked for F? Then we would be looking at the actual value or the values on the, you'd want to look at the Y values, Gabby, okay? All right, so when I see the words absolute, what do I need to do? It's a little bit different. What do I need to do on this one? And I know you didn't have time to do this one, so. There we go, good. We are gonna do a candidates test, also known as a T-chart, right? Before we do that though, we need to identify, and I know I technically identified them earlier, but we're gonna pretend we didn't, okay? We need to identify what our candidates would be, okay? We know we're gonna use our endpoints, and that's indicated there. We've got a closed interval, okay? But we would wanna make the statement that we know that f of x equals 0 implies that x equals -1 and 2. Okay, so you have to identify those values, and that's usually part of the points on this one. Okay, so I'm going to get out my giant T-chart because Mrs. Ballard likes to do her work in her T-chart. So -5, -1, 2, and 6, and we've got f of x. Okay, so I'm going to have to I have to get actually back to f of x, and since we're in f prime, what calculus does that mean we're going to need to do? So what calculus do we need right here? Thank you, Gabby. Again, good thing you all are taking the test, not me. Okay. All right. We're going to definitely integrate, right? What do I need to be careful of before I integrate? See, they're reading my mind, Mrs. DeWitt. They're ready. They are ready. Okay, we got to do that initial condition. Okay, so I'm going to start with 3. I could, I'm saving time on my test. Couldn't I start them all with 3 plus, right? They're all going to look like that. I could put my integral on them all really fast, right? And I know they're all going to start down here at -1. That was a terrible looking integral symbol. All right.
For my students, these are the boxes we draw for my students.
There you go. All right. Then we're going to do, this one's going to go, whatever x value goes to the top. So f of x, I'm just going to write them all out and then we'll calculate. And then this one's going to go to 2, and this one's going to go to 6.
And I'll f prime of x again. Thank
you. I apparently cannot get the prime on there today. I would be losing points all over the place. It's funny because I had that as a mistake when I went back through my work. I tried them earlier.
It's okay because now they'll just remember that tomorrow.
Yes. And you know what's happening? My brain's growing because I just failed, right? So it should be negative. Thank you. No, it should be whatchamacallit. Oh, I know where Jocelyn's going. Yes, Jocelyn, we want the bottom to be -5, but because it says I have to start at -1, what are we going to have to do to fix that? Yeah, we got to flip. Good job, Samuel. Good job, Jocelyn. All right, we got to flip it. So we've got 3, and I'm going to go flip to a minus from -5 to -1 of f prime of x dx. Okay. So I'm going to erase just a tad there because that doesn't look like a -1. All right, let's go back and look at our graph. So -5 to 1. And remember, I had written it in the earlier one. It told us right in here that that's equal to 5. So yay, they calculated that for us. So that's equal to -2. And this is probably one of the few times I probably go to simplifying my answer because I have to know which number is biggest and smallest. All right, what happens right in here? What happens with this guy? What's the value of that thing I just highlighted in yellow? Yeah, that's a good, we like seeing that one, right? They could put that one on the test like 500 times and we'd be happy because it's just a 3. All right, then I got to go from -1 to 2. So -1 to 2. So I need to find the area of that triangle. So let's see what I can do. 1, 2, 3. And then it looks like it's coming down 2. So this would be 3 times 2 divided by 2. What am I missing right now? I calculated 3. What am I missing about that? And why? So why is that negative? Okay, good. It's below the axis. So we're going to go minus. So this actually, this whole thing ended up equaling, what did I do wrong? I wrote it on the wrong line. Look at that. Boy, I'm having a good day, aren't I, guys? All right, so this was equal to 3. This one was supposed to be 3, and then we're subtracting 3. So that one equals 0. Okay, last part here. So we've got -1 to 6. So we're going to go all the way from -1. We already calculated that this is -3 to 6. So I've got to do the area of this triangle. See, 1, 2, 3, 4, base of 4. And again, it doesn't look proportional, right? You got to read the numbers on the graph. Base of 4, height of 4 divided by 2, which would give me that this is 8. So I'm starting with my initial condition 3. I am adding 8. I end up, oh, what did I do wrong? I forgot the -3. So 3 minus the 3 that's below plus the 8, I end up with 8. Let me double show you that again. So we had to do this and this. Okay. All right. So if your name starts with A through L, tell me what the absolute max is. And if your name starts with M through Z, tell me what the absolute min is. And this is first name. Okay. Well, Lorenzo's doing both. Oh, never mind. He's giving me the X and the Y value. All right, and this one, you guys, it's safest to just tell them the X and the Y value. You're not going to get marked down probably either way. So probably the way I would write this out is that, therefore, F has an absolute max. And again, you're writing out the words. You're not abbreviating like I am. 8 at X equals 6. You could also write has an absolute max of F of 6 equals 8. You can write it that way too. And then same sentence, but with an absolute min. F has an absolute min of what? -2 at X equals -5. Okay. All right. Should we give him a 5-minute break, Mrs. Dewitt? Yep. Okay.
Sounds good.
Let's do a 5-minute break. So it's 10:45, 10:50, and then we'll start again. Okay, guys? You're welcome, Gabby. We'll see you Monday. All right, you guys, you ready? Marilyn, you ready to keep count?
We
All
are.
right. Mrs. DeWitt, what kind of frogs do calculus use? Or sorry, what kind of calculus do frogs use?
Spot on calculus.
Not quite, but that's good too. Derivatives. Derivatives.
Okay.
There we go. Okay, count one. We're a little slower today than we normally are. All right. Oh, Samuel loved it. Okay, there we go. Okay, can't wait to see Mrs. DeWitt do some problems now.
Yes, if Mrs. DeWitt could connect her iPad. Oops. Let's see. Yeah. Okay, here we go. There we go. All right, guys, we are going to do the next part here, what is it, H? Hopefully you can see that. Yep, there we go. Perfect. All right. Write an equation of, first of all, I wanted to say, I think, I'm in my prediction mode. I think there's a really good chance you guys have what just happened? Oh, have a question like this on your AP test on Monday, because on the 2021 first round, the administration one, they didn't have one that asked about particle motion or a graph like this. So because they didn't ask this on the first test, I think there's probably a good chance we have one similar. So this is a good one to be doing today.
I would I would predict on both exams. Because there's a question about A, B, or both. I would probably say it's probably both.
Yeah.
So.
All right. Okay. So let's go when we see this, we get so excited because our favorite words on the whole test are tangent line or line tangent. When you see the words tangent line, what two things come to your mind? Type in the chat. There should be two words that come to your mind. Yep. Point and slope. We need a point and a slope. And so we have a point. We have an x coordinate of a point. So we know f of 5. And we need to figure out what is my y value when x is 5. So if we go back and we look at what we did up above, we get a little bit sad here because I was hoping that we had already found f of 5 earlier, but we have not. So we need to do something similar to what we did in part G to find f of 5. So f of 5, we have our, I always make little boxes here. So we know we need to put where we started. So we started at what was our initial condition, was at 3 and at -1 there. So remember these boxes are always your initial condition. And then where we want to go up here, oops, let me just switch colors there. This one and this one should always be the same number. So up there goes a 5. And so then we can go back and we can look at our area under our curve. Integral is the area under the f prime curve. And also sometimes people struggle to decide what to put here. But if you're looking for f, we need to integrate f prime, because the integral of f prime would be f. All right, so then we've gone from -1 to 5. So we go back up here, -1 to 5. I forget, I think we didn't divide this in part G, did we?
No, we didn't.
So we just had it as 8 or as 4 on that side.
Yeah.
So we need to cut it off now at 5 right here. So
which I thought was a super interesting twist on this one.
That is a pretty interesting twist, yeah. And so we started with 3, and then we from -1 to -1 to 2 we subtracted 3, And then from 2 to 4, I'm adding 4. And then I need to figure out what this little piece is right here, this trapezoid. So we hopefully all know the formula for a trapezoid, because you might be asked the trapezoid rule on your test as well. Area of a trapezoid, 1/2 the height times base 1 plus base 2. So 1/2 the height. The height is 1. Don't be confused thinking this is the height. Remember, your bases are always your parallel sides. So those are our parallel sides. So this is the height of 4. Again, it's not beautifully drawn because it's a little unclear, but it is 4. And then here, this is tricky too, because how do you know what the height of this is? I mean, you could kind of eyeball it and hope you get lucky, but really, we can feel confident that that point right there is at 5.2, if this point is at 4.4, because we've gone down 4 over 2. So I know the slope, down 4 over 2, the slope of this line is -2. So going down 2 over 1 would take me to the 0.52. So anyway, so that's how we get the height here. So 4 plus 2 are the heights of your bases. That's 6. 1/2 of 6 is 3. So this becomes 3. And so then we can add that 3 right here, and we get 7.
Mrs. DeWitt, I'm curious if anybody else saw that area any differently. If they saw another way to calculate that area. Does anybody have any other ways that they saw how to do that area?
Are you talking about just this? Are you talking about just this area right here?
The whole thing together.
The whole thing together? Okay. So you're talking about this whole area here.
Yeah. Did anybody else see another way to do that? No. So I saw it as the big triangle, which was 8, and I subtracted the little tiny triangle.
That's
instead
cool.
of doing my trapezoid. So just another option.
Yeah, that's a good option.
Yeah. I was going to go do the trapezoid first, but I'm lazy and I might not have remembered my trapezoid formula.
Well, the thing that made me do that is in the very beginning, just because I saw that this was kind of, I was thinking it would be a critical number here, I split it, like when I just first initially went through and I found all my areas without paying attention to what they were asking for. That's how I just happened to divide it. So.
Yep. It's okay.
All right.
Always good to have more than one way.
Yep. All right, so now we've got a point, and if it helps you to write it as a point so you can see it like 5,7, I usually do that just to get it fixed in my mind. And then we need to find the slope at 5. We have got a point. We need to find the slope. So the slope at 5. Oh, I think I spoiled it earlier. The slope at 5. If we go up here to 5. Oh no, I didn't spoil it. Okay, so. Ooh, I would like you to type in the chat for me, what is the slope at 5? What is the slope at 5? I think I could maybe trick some people on this one. Oh yeah, I'm getting them. I'm tricking them like crazy. It's not -2. It's tricky, tricky. Ooh, Erica, good job, Erica. So look at, we fell for it because when I was talking just a minute ago about the slope of this line here to figure out, I went down 2 over 1. This is really the slope of f prime. So really that would be thinking about f double prime. So f double prime at 5 is -2. But f prime is just, it is what it is. And so f prime is just your y value here, which is 2. That's tricky. That was probably get some people that year. So the slope f prime equals 2. We okay with that? Any other questions about that? It just is what it is. I always in my classes sometimes I'll say, if we're talking about f prime, and the graph is f prime, I like to think it's matchy. When they're matching, it just is what it is. If you're looking for the sign, it's above or below. If it's above, it's positive. Below, it's negative. If if you're looking for the point, it just is what it is. So when they match like that, you're just looking at the actual value. All right, anyway, so now we've got our point and we've got our slope, so we can do the point slope formula. So let's write that point slope formula out. I'm going to write the formula out just in case you need a refresher on it. So it's y minus y1 equals m times x minus x1. And then we plug in our point. Y minus 7 equals slope 2 times x minus 5. And that is your tangent line. Don't simplify it. Don't distribute. Don't try to do anything fancy to it. I will say if this problem is all in terms of t, then I would change the x to a t, but don't change the y. Leave the y's as always. Just leave the y's fixed. Again, they're kind to you on the AP test. If it was supposed to be a t, they say they look at it sideways and give it to you. But technically, you would be able to change that to a t if our whole function was defined in terms of t. Okay, now we need to use this tangent line to approximate f of 5.1. So when they ask us to use a line to approximate, that's when I change the y. I like to say, all right, well, we know that y is the same as f of x. And then I would clean it up a little bit. I'd leave it like that and then add that 7 over to the other side and move that 7 over here. I don't distribute this. I never distribute the number out in front into the parentheses. It's usually
me either.
Yeah,
I'm lazy.
It's a lot. You make much fewer arithmetic mistakes if you don't do that. All right, so then we've got 2 times, and then we can plug in my x, f of 5.1 minus 5 plus 7. And you can leave your answer like that. And actually, I'm going to say approximate. 5.1 is approximately. You're not going to lose a point for that either if you don't put the little squiggly signs, but it is technically correct. I mean, yes, this is the same as 2 times 0.1 plus 7, or that ends up being 7.2. You could write 7.2, but why if you're going to risk making a mistake? So you can leave it like that. It still bothers. Doesn't that bother you, Mrs. Ballard, that they don't have to write 7.2?
I've gotten over it.
Yeah, I'm not over it yet. So, all right. So that's that one. Let's move on. So we love tangent line problems. Let's see what's next. Ooh, these are fun ones too. Let f be a differentiable function. Okay, we got all the same directions here. But now it says, suppose g of x equals this whole thing. We need to find g of 3, g prime of 3, g double prime of 3. I think I want to give you 3 minutes to attempt this one first on your own. I'm going to do a little pop-out timer here for 3 minutes. That's a minute apart. So let's see how far you can get for 3 minutes. So try this one first without me. So 3 minutes, this might be too long. We'll see. When you think you have all three parts maybe correct, put a smiley face in the chat. When you're done and you think you have, if you think you did them all right, give me a smiley face. Or that means you're done, but you're not confident they're correct.
Oh, Marilyn. Hmm.
Oh, show the graph. There you go. Usually in the free response questions, these are you get a point for each part. So this would be like a 3-point question, which would be awesome. All right, 8 seconds left. We're going to stop that timer there. Okay, so go ahead and type in the chat what you got for the first one. This first one, 3 to 3. That's a quick one, right? Well, you know, if the area under the curve from 3 to 3, if you have no space you moved over, you have no area under the curve. So we get 0 there. When you see this notation, we know we should always just derive. You should, when you derive it, this just gets popped right in there. So g prime of x is the same as f prime of x. I will say this is a little different than some of the ones I've seen in the past. A lot of the times in the past, I feel like they're just f of x here or f of t here, but it just gets plugged in right what it is. So you replace the t with an x. Do be careful because they like to add little twists. Now, if there was a number in front, say there was like a 4x here, then we'd be plugging in a 4x, and then you have to multiply your answer by the derivative of whatever's up here. So the derivative of 4x would be 4. If for some reason the constant was up here, they had these switched around, then you'd have to switch them and make it negative. You need the variable to be up here and the constant to be down there. All right, so now when we know that g prime is equal to f prime of x, now we just plug in 3, f prime of 3. So we look, what is f prime of 3? Now remember, this is the f prime graph. So f prime of 3, type it in. What did you put for that one, guys? Good. Yep, it is what it is. So it is, the y value is 2 there. And then this last one, g double prime. Well, if g prime of x is f prime of x, then g double prime of x is f double prime of x. So f double prime of 3 then. And that means, now this is what we were talking about, the slope at 3, the slope of f prime at 3. So now we're actually talking about the slope here, which was up 2 over 1, up 2 over 1. So your slope was 2. So that could be a nice 3-pointer. All right, let's see what's next. If you answered questions A through E, but with g of x, why don't your answers change? If you answer questions A through E, but with g of x, why don't your answers change? That's kind of a weird question.
It is a weird question. I kind of liked it though. Only because it just there. I think he's just trying to point out that your g of x and your f prime of x were equivalent, or when you or that f of x are equivalent.
Yeah, well, if the derivatives are equal, the concavities are equal, then the functions would be equal. So we'll just say, I'm just gonna say g and f are the same graph.
Yeah, they would not probably ask us that part.
No, I've never seen that on any really. But
it was a good point. It made us think for a minute.
Yeah. Oh, wait, you know, but they aren't the exact same graph, are they? Because they could have an initial condition. They could have different and the same. Wait a minute. The same graph because they have the same slope, the same concavity, but what if they had a different initial condition?
Maybe not the same graph, but they equate to the same function.
I was looking at the answer key. It says G and F are the same graph, but with different initial values, so concavity doesn't change. Huh. Because we don't have an initial condition for
G of X asking.
I don't know. I don't think we should spend more time on it because I don't think we're gonna have anything like that.
Don't worry about that one, guys.
Moving on.
But I like the thoughts that we're thinking in the chat. There were a couple comments of it.
All right. Okay. If V of T equals F, is that an F prime? Yeah, it looks like that's an F prime there. That's kind of hard to see. I'll make it bigger. If V of T equals F prime of T is a model for the velocity of a particle moving along the x-axis. So they're essentially saying, okay, guys, now this is a velocity graph because this is our F prime graph. So they're saying, all right, we're going to call this velocity. Is the particle speeding up or slowing down at time equals 3? Justify your answer. Ooh, good question. I can definitely see something like this popping up. Pop in the chat for me the two things you need to be careful to consider for speeding up and slowing down. Oh, I see. Isn't G of X asked?
That was the previous one.
Okay. So yeah, so velocity and acceleration, I see you type in, yeah. So we've got to check both of those. So remember, for speeding up, V of T and A of T would have the same signs. And then for slowing down, V of T and A of T have opposite signs. Or you could say different. What do you say, Mrs. Ballard? Do you say opposite or different?
I usually say different, but
okay.
It doesn't matter. They're the same. That's
Yeah.
the same thing to me. So
I think I usually say different, but I don't know why I put opposite there for a minute. Okay. All right. So let's go ahead and we need to find out what is the velocity and acceleration at time 3. So we need to figure out what is V of 3 and what is A of 3. So take a moment, see if you can figure that out. What's V of 3? What's A of 3? All right, type in the chat for me what you're getting for V of 3. V of 3 equals what? Good, yep, because it is what it is again. We're just that point right there. When X is, or when, yeah, X is 3, or in this case T, they changed it to T on S, so T is 3, so then velocity is 2. And then go ahead and also tell me what the acceleration is at 3. Yep, I see a whole bunch more 2's. I might put in there V prime of 3 equals 2, just so we understand that, you know, the velocity is the acceleration is the derivative of velocity, or the slope of velocity. And there we go. This is greater than 0, and this is greater than 0. So I can say the particle is speeding up at t equals 3, since V of 3 and A of 3 have the same sign. And now that I'm thinking about that, would you have to put greater than 0? I would say no, you do not have to put that they are greater than 0. I usually do, just to show that they're positives or negatives, but as long as you explain it in your explanation here in your sentence, I think you're okay. The other thing I would note that I would include this. I'd make sure to write this step because of the same reason that we were talking about before. When you refer back to the graph you're given, they didn't give us the acceleration graph. So if I just say a of 3 is equal to 2, that's I know that from looking at it, but we really should say y. And so we should make a reference back to the graph that they gave us. And since they gave us the velocity graph, don't just say a of 3 equals 2. Say how you knew that it was 2. Would you lose a point for that? Probably not, but maybe. Why risk it?
Yeah. The 3 seconds or 2 seconds, maybe 1 second it takes to write it is not gonna is worth saving the money on college tuition.
All right, moving on to L, because the parts never end here. So let's see what's next. You're going to be so prepared because we've done everything you could possibly do on a problem like this. All right, we need to find the limit as x approaches 2. So what's the first thing, your first instinct when you have a limit? What do you want to do? Type it in the chat. Every time you have a limit, yep, thank you, Marilyn. Yeah, plug it in. See what happens. You plug that in and we get f prime of 2 all over e to the 2 minus 2b 0 minus 1. And then the slope at 2, f prime of 2, it is what it is because that is the f prime graph. So my slope is 0. And then here I've got to be careful because I don't want to do equals 0 over 0 because that's that dangerous thing that we lose points for. And the reason why, well, this is a fairly new thing for I think a lot of us calculus teachers, but my understanding is that the reason why we don't want to say it's 0 over 0 is because this is indeterminate, and this is not indeterminate. It has a limit, so we're not going to equate something that's not true. So if this is indeterminate, and this isn't, you can't say it's equal to 0. So on these problems, you never, never, never put the equal signs. You can put 0 over 0 off to the side, but don't set it equal to something that's indeterminate. So if you get 0 over 0 and you put an equal sign, because that is my first instinct to just start doing the equals, don't leave the equal signs. Instead, now we know because it's 0 over 0, what rule are we going to be using? Type 2, you can do, yeah, thank you. I was just saying type 2 letters. Yeah, L'Hopital's rule. And for L'Hopital's rule, because we know it's 0, 0, we have to do the limit as x approaches 2 of the top, f prime of x, and then we show that equals 0. And then we do the limit. I guess I could do this. Let me write. I just plugged it in because I put that there. I'm going to say equals f prime of 2, which equals 0. And then we do the limit as x approaches 2 of the bottom, e to the x minus 2 minus 1, which would be e to the 0 minus 1 is 0. So that's how we're going to show that both parts were equal to 0 here. So don't put any equal signs up here. Do it this way. And then we can say by L'Hopital's rule, and you don't have to write it out, but I like to just say by L'Hopital's rule so we can see that what method we're using. Then we go ahead and derive the limit as x approaches 2, f double prime of x all over the derivative of e to the x minus 2 is e to the x minus 2. Chain rule times 1, but that just goes away, and then minus 1 goes 1. Okay, so go ahead and do that now. Figure out, plug in your 2 and see. Sometimes we have to do L'Hopital's more than once. See if this is a case where we do or not, do or don't. Again, I put the equals, but being careful about that because, again, if I get L'Hopital's, I'm going to erase those equal signs. Oh, but now I know because of the denominator, I'm going to be okay because on the denominator, I don't get 0. F double prime of 2, the slope at 2. What is my slope of F prime at 2? My slope there, 2. The slope of this line is tempting to want to put 0, but we're looking for the slope of the F prime. So that slope was up 2 over 1 again. So we get 2 over e to the 0, which is 2 over 1, or just 2. And so now I can leave the equal signs because that actually is what the limit equals. All right. By the way, I feel like all of these examples that we do end up being 0 equals 0, but it is, you can do L'Hopital's if you have infinity over infinity too, or negative infinity over infinity. So you'd go through the same process.
You can also split your limits like that up too. It just automatically, even if they come out to be something that's not 0 over 0, 0,
Yeah,
and then you can always put them back on top. So it's safe to split it every time.
Right. All right, moving on. Let's see. Oh, we got another part, M.
Just moving on to M.
Oh, this is back to a part we kind of did earlier. Yeah. Looks like another deriving an integral. So let's go ahead and do that. So try that. Start at B. I'll give you you get about a 30-second head start to me. So go for it. Okay, bye, Erica.
Bye, Erica.
I know a bunch of my kids had track meet today.
No, maybe Gabby ran. That might be what Gabby was doing. Gabby ran on Thursday. I know that. I snuck up there and watched. Our track team is really small.
Okay, so the area under the curve. Oh, I'm gonna steal my my numbers back that I had before. I don't want to have to rewrite those all. Take all of those back from me. Copy and paste. There we go. So the area under the curve from -5 to 3. Oh, look, they cut it off for me again, man. Making me do some more triangle work there. Now I gotta do that. So now I've got to know that little piece in there. 1/2 base times height. So that's just a little 1, but then that messes that up, makes that a 3. Oh, which I guess if we did it Mrs. Ballard's way before, she would have already figured out that that was 1. All right, so then we've got -5, 3, oh. Okay, yep. And so we've got 5 minus 3 plus 1, 3. Oh, wait a minute. Do we have an initial condition that we need to worry about here?
I didn't see one on that one because they changed the function to h.
Yeah, but
Are you looking at? I didn't look at the answers though.
Actually, look at the answers. Okay, wait. The answer is very different than what I have. The answer is pi on my answer key. What the heck?
There's no pi.
That's
what I get for borrowing someone else's answers. I think I got under the check. I think I got what you got.
Yeah, I don't see what else we could have. So yeah, that's interesting. All right, so let's go with that. And then let's look at.
Oh, wait, Mrs. DeWitt. It was, hold on a second. It was one time. No, you're fine. I did a wrong area, but you're fine.
Okay.
I agree.
All right, let's try to find h of 6 then. H of 6 is the area under the curve from -5 to 6.
Doesn't it start at -3 instead of +3?
-3 instead of +3. I'm not sure what you're talking about.
Because on our worksheet, it says h of x is equal to the integral of -3 to x
It
for
does?
f prime of ft.
That's -5. That's a 5.
Oh,
Right there? You're talking about right there, right?
Yeah,
Yeah,
it's a
that's a
5. It's a -5.
They are kind of hard to read, though.
They are. Sorry.
Okay, so let's look at, so -5 to 6 would be going all the way across. So all the way across is, let's see, is 5 minus 3 plus 8. Let's see, it's 4 and 4 is 8. Yep. So it would have been 10.
That's what I got.
Perfect. Okay. Yeah.
Correct, Marilyn. All right, I think that's the end of Mrs. DeWitt's problem.
Yay.
Mrs. DeWitt, aren't you so excited, or aren't you so happy to be a calculus teacher?
I am.
I'm really glad I signed up for this. All right, you guys, we're going to do a 2-minute break, okay? All right, there we go. Count 2.
Oh my
There we go.
goodness. You know what, Mrs. Ballard?
wrong? What did we mess up on?
We're not taking our break yet. That problem's wrong.
Okay. What did we mess up on? Because I messed up the same way you did.
Oh wait, never mind. Oh gosh, because I can't see. I thought it said for a second. I thought it said h of x minus, and then never mind.
No.
But it's equal. Okay. We're not wrong. Never mind. I lied. Okay.
Good. All right. 2-minute break. Okay. 2-minute break, everybody. Get up, move around, do the derivative dance really quick. 2-minute break.
Mrs. Ballard.
Yes.
Okay. So does the problem say that h of x was equal to the integral of f prime of t?
Yes.
So wouldn't we have found the area underneath the curve, since that's a graph of f of t? F prime of t?
Yeah, we would have found the area under the curve, which is what she did. Because it was a graph of f prime, and it was you had to find the area under the curves. I think we're good.
It still does bother me that we don't have an initial condition.
I know it bothered me too, but there wasn't one on there.
And then the other thing I was thinking about with that problem was that, I mean, really I was thinking, well, because we don't have an initial condition, can we just do like old school integration? Because the integral of f prime would have been f of t from -5 to 3, which would have been f of 3 minus f of -5. But we don't know f of 3, so that doesn't help. Like I thought maybe they gave us that, but they didn't give us that. So
yeah,
it's not a great question, because I'm hesitant about that lack of initial condition.
we are paying for stealing someone else's problems.
Yeah.
All right, about 1 more minute, everybody, and then we're gonna switch over here. Let's see, we've got about half an hour left.
Which one are you gonna do?
I'm just gonna keep going with the.
Yeah. This is a good one, because those are those increase, like in and out problems, I think, with the, right? Is that where it goes?
I didn't get to the bottom of this one, so I'll do the first 4 parts. How's that sound?
Okay, that's good.
All right, there's our 2. I've got to share my screen now. Get back to this.
I'll stop sharing mine.
It's okay. I think I can override you. Does it work? There we go.
Yeah.
Okay. All right. Hey, Mrs. DeWitt, before we start, what do you call recycled calculus jokes?
Recycled calculus jokes. I don't know.
Derivative humor.
Okay, I get it.
All right, you guys. We're going to move on to a tabular stem. Who's excited about having a tabular stem? I know I am. I love tabular stems. So we've got a sand pit. That sometimes makes me nervous because it makes me think the cone problem is coming, which my students who are in BAB don't know what that is because I didn't do it. We're going to hope it's not there. If it is, it's not worth that many points. So a sand pit is filling up with sand whose height at time t is given by the differentiable function h of t with domain between 0 and 12. Let h prime of t be a differentiable function representing the rate at which the height of the sand pit grows in inches per minute. It is known that h prime is increasing its entire domain. I typically, when we see these, sometimes they will have the word strictly in there. I kind of would have liked to see that better. Values of h prime of t are given at selected values in the table above. The height of the sand pile is 40 inches at t equals 9 minutes. When you see this word, I'm curious because this hasn't come up quite yet today, and it might come up later, although I might be stealing Mrs. DeWitt's thunder. When we see that word differentiable, what does that imply? What does that imply when we see the word differentiable? Because I just needed to hear from everybody in the chat because I was feeling kind of lonely. All right. It implies continuous. So we know that we've got a continuity if we're differentiable. All right. So we're looking for h double prime of t with units. Explain the meaning of h double prime in the context of this problem. So what am I going to do to find h? If I have h prime here, I need to find h double prime. What am I actually calculating in this problem? All right, that's right. It's all about the slope, right? Okay. So 2 happens to be between 1 and 3. So these are the values I am going to use for my slope. So I would label it h double prime of 2 equals 5 minus 2 over 3 minus 1, which in theory, yes, I should probably leave it there. I shouldn't go any further, right? But I know Mrs. DeWitt's watching, so I'm going to write 3/2. Okay, so we want to make Mrs. DeWitt happy. All right. All right. Luckily, I did the arithmetic correctly, hopefully. Sometimes I don't, and then I would have gotten it wrong. All right, now we have to explain the meaning, okay? So we kind of have to be careful. I always like to go back in and look at what my problem said. It said it was representing the rate, the height the sand pit grows, and we just took the derivative of a rate. So we have the rate of a rate, okay? Typically, when we have the rate of a rate, we want to talk about if it's increasing or decreasing. So what do we think about in this one? Do we think it's increasing or decreasing? Why is it increasing? Why is it increasing? Help me out with that. Why is it increasing? Okay, I got a lot of different things. Okay, and we can't just say, so you've got to be specific. Okay, you want to talk about that the derivative was positive, right? That's the reason that it's increasing. I'm not sure we actually have to put that in our explanation because that's not, but we want to make sure you're clarifying that in your own head. So I would probably write something like h double prime of 2 represents, and I swear every time I write a sentence about this, I write it differently. The rate of the height of the sand pit.
Did you mean to write the rate twice?
Yeah.
Okay.
The rate of the height of the sand pit grows is increasing because we've got a derivative of a derivative. That's why I wrote it twice.
Yeah.
Time. Do you not like that?
I don't think I do.
3/2 inches per minute squared.
Because I would say whenever you say the word increasing, you're already
So
talking
this-
about, yeah, that's
Okay.
good.
There we
But
go.
I always think of it as like, if it's increasing, that's already talking about the derivative. So
True. And that's where I probably lost it this morning when I first did it. So, all right. We're going to talk about part B.
and one other thing, guys, I would make sure you pay attention to when it on, because if it says this on your test, when it says with units, you have to have the units there to get that point. And so that's super important.
Yeah, you want to remember NUT, which is nouns, which means repeat the stem, right? Units, and then time. So you always want to include time on everything, okay? Or like, can I also kind of imply an interval if there's an interval there? All right, let's look at B. We've got a nice right Riemann sum. I love Riemann sums. I don't know if I like Riemann sums better or curve sketching better. It's a tie, I think. So use a right Riemann sum with the subintervals given in the table to approximate 0 to 12 of h prime of t. With units, explain the meaning of 0 to 12 h prime t in context of the problem. Okay, so typically they will give you a number of subintervals. Okay, this one just didn't. All right, so we're going to assume the number of subintervals that are listed in the table. They kind of implied that with saying this, but typically on the actual AP test, they say, hey, it's 3 subintervals or 4 subintervals. And it does say approximate, so I would probably be more comfortable writing an approximately symbol here. All right, I'm going to zoom out a little so I can see my table at the same time. All right, so in my table, I'm counting 1, 2, 3, 4 subintervals. So I probably do this again a little bit different than other teachers do because this is just the way my brain works, okay? It says I'm coming at it from the right. So I am going to start writing things from the right, okay? So I remember that I'm coming from the right. I don't draw the rectangles. I know Mrs. DeWitt likes to draw rectangles.
I do.
So I'd say, okay, we're look at the distance in between. I'm going to get my base and my height of my rectangle. So my distance in between is 3 and my height is 10. And then my distance in between is 3 again and my height is 7. My distance in between is 2 and my height is 5. And my distance in between is 1 and my height is 2. And that way I know if I write it from the right and I come from the right, I know that I've gone the right direction, okay? All right, so now, should I go any further? Should I keep going? All right, I didn't get anybody yelling at me. Like there were no capital no's. Normally there are a few. I know Marilyn will do it now that I've said it. All right, so we should just stop there. And that's usually kind of worth 2 points of stuff right there. That's pretty good 2 points. Again, you don't want to make an arithmetic mistake. You're going fast. You want to have time for, from the distance is 6. Did I even make a calculator? You're right, Marilyn. No wonder you didn't yell at me at no. Okay, so let's see. 3 to 9 is 6. I got to fix this one right here. There we go. Okay. Apparently I can't subtract today. All right. It's okay. I made a mistake, so my brain grew. All right. With the units, I like it because I'm old so when my brain grows, that's a really good thing. Okay. So with the units, explain the meaning. So this would be, so actually, you guys help me out with this one in the chat. When I integrate the rate that the sand is growing, okay, what do I actually get back to? Okay. Thanks, Marilyn. What do we actually get back to? I want to hear from a lot of people. What do I actually get back to? Got 2 so far. Want to make sure we're here and awake and paying attention. I like that we're being lazy today. Let's make sure we write out the whole word on Monday. Okay. All right, so we get back to it's the total that the height is growing. I like that Lorenzo listed out the height of the sand pit. So I would probably be, yeah, I could go with height. So the integral, because it was the rate of the height. So the integral from 0 to 12 of h prime of t dt represents, I'm into the word represents today, I guess, the height of the sand pit okay. What am I still missing? What am I still missing in my explanation? Because there's two things I'm actually missing. Yeah, I'm missing my units and my time. I would probably put you, even though it's awkward, I would probably put my units after this. Okay, and I might say them again in my explanation. So my units would be, let's see, it was in, I'm looking, inches per minute. So this would have been in inches, right? And then the height in the sand pit at time t equals 12 minutes. And then maybe say and measured in inches per minute, or measured in inches. Oh, you know where I should have put the in inches? The height. I'm going to squeeze it in there. In inches. Sorry, I'll blow that up so you can read it. Maybe. There it is, the height in inches. And on that one, if you totally forgot your Riemann sum, you could write your explanation and still get the points. Okay. Look at part C. So part C is asking, did we have an over or an underestimate? I want to hear from you guys. What do you guys think this is? Over or under? Over or under? Okay, so the big question is, why is it an over or under? So what I like to do, this is the one time I go back and I draw my picture, right? Remember how I was picky about these words in here? I said I liked the word strictly increasing better, but you could also see it just from the values going up in the chart. But I would draw myself an increasing function and I would start drawing rectangles. I'm coming at it from the right. I know that I am over. So I would say our answer, and sometimes they put these together in one part, in B is an overestimate because H prime is strictly increasing. I added the word strictly in. Strictly increasing. And we used a right Riemann sum.
And for those students who are confused by the word strictly, that just means it's always increasing.
Yeah.
And it does kind of say that in the problem because it says it's all, the sand is always growing. The pile is.
Yeah. I just
growing.
like the word strictly better.
I do too, yeah.
See, Mrs. DeWitt and I think a lot alike. All right, I'm going to do one more part with you. All right, let's see. Okay. Including units, we have to evaluate. All right, so Mrs. DeWitt was trying this earlier. I kind of like this one because it's pretty nice. So I have H double prime. I've got to integrate it. And the only information I have is H prime. So when I integrate H double prime, you guys, what do I get? Can you put that in the chat for me? All right, I'm liking what I am seeing. All right, so we would get back to H prime. So I would say that this is H prime of T, and we have to evaluate from 0 to 9. h prime of 9 minus h prime of 0. Look at how nice this is. And h prime of 9 is 7 minus h prime of 0 is 1. And you could stop right there, or you could write a 6. Your choice. All right. How's everybody doing? Give me a smiley face rating in the chat. How are we doing? All right. Still waiting. Oh, Jonathan's super excited, Mrs. DeWitt. You should do some extra calculus with him today.
He's probably super excited because it's almost 12 o'clock.
You would, I don't know that they would knock you off. They probably call that a spelling error, Tina. But I would try very hard not to change your cases. Okay. All right. So, Mrs. DeWitt, why did Newton invent calculus?
Because he wanted to prove Leibniz was lying.
That's pretty good. But I think Leibniz came after Newton. All right. But he wanted to test his limits. Invented during a pandemic. So our students could have been sitting at home inventing another part of calculus. Who knows? All right. I am going to stop sharing and let Mrs. DeWitt take over. Marilyn says she's, well, Newton didn't have to go to school like you guys do. He could have done it last spring, though. On the last one. Oh, I did miss the units, Cynthia. You're right. So our units should have been inches per minute. So write inches per minute on it. You'll work on it during the summer. Okay, good. Bye, Samuel. You're welcome. Have a good weekend. See you Monday. Mrs. DeWitt, you're muted.
Oh gosh, one of these days, we'll figure it out. But okay, so I always get to take over the best question because we once again get super excited when we see the word line tangent. So let's go ahead.
I knew you loved it.
Find that tangent line. I do. That's my favorite type of problem. So we need our point and our slope. Do the point slope formula. It's kind of interesting though. In this one, we're using our tangent line at 9 to approximate 10. Usually it's we're always approximating a decimal.
I'll have to get it out and show her, Marilyn.
So first I was thinking, gosh, how do we find h of 9? Because we only have a table for h prime, but then we read the directions and it says the height of the sand pile is 40 at time equals 9.
Mrs. DeWitt, this is our shirt this year.
Oh, that's cute.
But it's for our tangent lines because we repeatedly said point and slope in the chat all year long.
Nice. All right, and so then we need a slope. So we need to find h prime at 9, which that should be pretty nice because they just give it to that's given to us in our table. H prime of 9 is 7. So we have a point and a slope. We do the point slope formula. So I'll give you a 20-second head start to me. Shouldn't we have RT? Oh yeah, thanks a lot, Mrs. Ballard.
Are they complaining that you don't have a t-shirt?
Yeah, right. Wear your lucky shirt, kids. With no math symbols on it. You do know you can't wear math symbols to the chest.
I know. We're good.
I don't know my kids knew that. I should be common knowledge, I guess, but can't wear your derivative rule shirt to the test.
No. I wouldn't put a derivative rule on the shirt. I might
No.
put an integral symbol. I think we could get away with an integral. You're not supposed to, but I wouldn't put a formula on a shirt. Then we can't wear it.
No. They have rules on the College Board about, like, if you have a tattoo, you have to cover it up that has math symbols.
I don't think that the social studies teachers that are proctoring the test are probably going to read that rule. So they might catch a real formula, but they might not catch an integral.
And I don't think they're covered in math tattoos. So I think that we're okay there. So
no, yeah. Well, they might make some this weekend, but
all right, so here, my first instinct again is to write it like this. I would write my point slope because I'm just always use y's and x's. But like I said in that last one that we did, because this problem is actually in terms of t, to be technically correct, you should do t minus 9 there. So there's our tangent line. And the reason why you don't, like, right now I'm going to, when I approximate h of 10, I'm going to go ahead and write it as, okay, I'm going to say this is really h of t, y is h of t equals 7 times t minus 9 plus 40. But if you're wondering, like, why do I change this to a t, but I don't change the y to an h when I write my tangent line? It's because if we have a graph of h, I don't know what, let's just say there's my graph of h. That's h of t. When I'm finding a tangent line, let's say there's my tangent line I just am working on finding. The x-axis is t here, but that line is not the h line. That line is still in terms of like some y equals mx plus b, but now because the x-axis is no longer x, it's t, we don't change, like h is different than the equation of this line. So that's why I don't call this h yet, because it's not this curve. H is a different curve than whatever this line is. We're just using this line to approximate 10. So like if I didn't draw this I didn't choose a very good location, but let's say this was 9, now this is 10. I'm going to use this line. So I'm saying, oh, it's close, 9's close to 10. On my tangent line, my value will be a little off, which is why it's just an approximation there. So I'm going to say h of 10, approximately, h of 10 is approximately 7 times 10 minus 9 plus 40. And it hurts my heart again to leave it like that. But that is equal to, just because I can't just let it go.
Mrs. DeWitt, I would add one thing to what you've done. I like it. But they did not, usually in the problem, they'll say like y equals f of t. And they didn't in this one. So I would probably add into your work like y equals h of t somewhere.
Y. Oh, you would say like over here, like h of t equal to y.
Yeah. Just to be clear, because then you're not directly substitute or let whatever h of t equal y, something like that.
What I did right here, but it was more direct.
Yeah.
I'm good with that. Okay, so that's our approximation. Let's go ahead and see what's next. Explain, oh no. Explain why there must be a value of C.
For the last problem, shouldn't we have talked about an over approximation or under?
Oh, thank you. Thank you. I didn't read the whole question. So is this tangent line used, is this an over approximation or under approximation of the true value of h of 10? Okay, so to determine whether tangent lines are an over approximation or under approximation, we need to know about what? Can somebody type into the chat what we need to consider? What do we need? How are we going to need to know if my tangent line is an overestimate or an underestimate? It's not going to be. So here's why increasing and decreasing isn't necessarily correct. Because if a function's increasing, this is increasing, but so is this. If if I drew a tangent line here, it'd be an overestimate, and here it'd be an underestimate. So increasing isn't sufficient enough to determine whether it's whether the tangent line is above or below it. There's something else we need to think about to determine whether tangent lines are, concavity. Because now let's see why that is. So if I have a graph that's concave down or concave, sorry, I said that backwards, concave up or concave down, and I do a tangent line, tangent lines on the graph that are concave up are always going to be an underestimate, and if it's concave down, it's always going to be an overestimate. So for tangent lines and over or underestimates, we need to think about our concavity. So I need to figure out at 9, what is, I need to know what H double prime at 9 is. What is the concavity at 9? So how are we going to determine that? Think about that for a minute. And your clue could be found right here. If H prime is increasing, remember, think of the word increasing as your derivative of whatever you're talking about. So if it's increasing, then we know it is positive. So H double prime is actually, I can't say equals because we don't know, but we know it is greater than 0 since H prime is increasing. So since H prime is increasing, we can say, therefore, you use my 3 little dots, the tangent line is an overestimate. So always think concavity for over and estimates for tangent lines. All right, which is different than what Mrs. Ballard did back in that the right hand and left hand Riemann sum. Then you, for right and left Riemann sum, overestimate, underestimate, then you need to think about whether it's increasing or decreasing. So always draw a picture and see if that helps you. All right, moving on. F. This might be our last part here. This would be a good one to end on because this is
this is
a tricky one here. So explain why there must be a value of C on 9 to 12 such that H prime of C equals 8. Did I ever draw this out? I did draw mine out. I'm going to go ahead and steal my graph from up above earlier that I used. Copy. First of all, the reason why I know that I don't love this problem is because whenever you see must be a value of C, you know it's one of your theorems. It's going to either be your MVT, IVT, EVT, although we don't use EVT very much, that's extreme value theorem. So it's probably MVT or IVT. Now, the mean value theorem has to do with your, that's when you have a secant line and you're trying to find some other C that has the same slope. The intermediate, that's mean value theorem. The intermediate value theorem just says it takes on every value between 2 points. So like if you have a point here and a point here, that's -2, that's 10. Then they're saying there's a value everywhere, like f of 8 would exist. There's a y value for every value between whatever the two you have. Okay, so this one wants to know from 9 to 12. So here's my graph, 9 to 12. It says that H prime of C must equal 8. So knowing that mean value theorem, you're trying to find when the slope, a location where the slope of the tangent line equals the slope of the secant line. And intermediate value theorem, you're trying to justify that there's points in between two other points. Type in the chat for me. Do you think this is an MVT or an IVT problem? What do you think, MVT or IVT? Good. I see lots of IVTs, and you're correct. And that's, but to me, this is a tricky one because usually when we're dealing with, like, we see slope, we think MVT, but this one is we're not thinking about the slope of H prime. We're just thinking about what H prime is here. And so when we're justifying an intermediate value theorem, there's a couple of words that are super important that we have to list. In fact, Mrs. Ballard, I really like that chart that you sent to me. I posted it in my Google Classroom, the cram chart here.
Oh, yeah.
And I like, for those of you who are going to study a little bit more this evening or crash course tomorrow, I would read through this whole chart, just read through it, and especially paying attention to the sentence to write for IVT is down here, and then the sentence to write for MVT is up here. I liked what they had as their sentences, so I'm going to steal their sentence right now. They wrote, since, okay, so we're going to adjust their sentence to our situation. Let's see if I can move this down so I'll just write it over here. Okay, get rid of that. So let's steal their sentence but adjust it. So it says, since, now instead of f of x is continuous, I'm going to say my f of x is my h prime of t, because that's what we're talking about, is our h prime graph. Since h prime is continuous on, and then we need a closed interval on, and in our case, it's 9 to 12. And h prime of c. Oops, you can't see that. There we go. Move it over a little bit more. There you go. So all I'm doing is I'm changing all my f of x's to h primes. So now and h prime of c is between h prime of A is 9, and h prime of 12. By the IVT, there exists a C in 9 to 12. Notice that now it's not brackets, because it has to be between these two. It can't include those same points. Such that h prime of c equals what? Oh, equals our number, equals 8. There you go. So I like that. Probably the most important words that you say in this whole thing are that it's continuous, and then just the conclusion that there exists a C. So, and it's super important that they, you could also stay on the closed interval from 9 to 12. So continuous and closed. I actually have a formula sheet for theorems too that have big words, like for IVT, you need to say continuous and closed. For MVT, you need to say continuous, closed, and differentiable. But by putting in closed brackets, you're saying closed. So again, I'd look over those theorems. All right, it is 12:03, so I think we are going to wrap this up. And my best advice for you guys is don't panic. Like, there's probably going to be some free response question that you don't know how to do very well, and if you see it and you're just like, I can't do it, I'm going to fail. Go on to the next one and let your brain rest on the other one. So just don't panic. Remember, you don't have to get a lot of points to pass. You have to get about 3 points per question on the free responses. So just stay calm, and if you don't know how to do something, go on to something else. So good luck. Get a good night's sleep the night before. Eat something good for dinner, and hope it all goes well for everybody.
Yeah. I would totally second that. And then I just put the link to all of those like quick review kind of sheets in the chat. I know we've got a few people who may not have gotten them. So